Hello dear students, this is your Jagan sir. Welcome back to our YouTube channel Physics with Jagan sir. And we have successfully completed 6 classes on Newton's laws of motion. And today is the 7th class. And in this class we are going to see basic constraint relations. And constraint relations depth knowledge is not there. Actually, nowadays in the examination they are not asking direct questions on the constraint relations, but I am going to give you a knowledge on the constraint relations which is sufficient for writing your examination, right? And before we are going to see constraint relations, let me discuss three important small concepts over the constraint relation. Number one is, let us see the case when pulley is attached with two masses or attached with two masses like this, and in such a case the pulley is moving in the downward direction with the displacement. It has moved a displacement xp in the downward direction, that pulley. And suppose mass a is moving in the downward direction xa, and mass b is also moving in the downward direction xb. And I hope I would like to tell you one thing here. It is a part of the situation, it is a part of the situation. And don't get confused that when it is moving in the downward direction, how it can move in the downward direction. Obviously it has to move in the upward direction, but it is a part of the situation. I will let you know definitely at what condition it is happens in our today's class only, right? And suppose here a situation arises in the given question that the pulley is moving in the downward direction, and xa is also moving in the downward direction, and xb is also moving in the downward direction. Then remember, here I need to use xp is equals to xa plus xb by 2 as the formula. Similarly, the next situation says that if pulley attached with xa, xb, and pulley is moving in the downward direction xp, and xa is moving in the downward direction, xb is moving in the upward direction, and in such a case you have to write it as the direction of pulley we are considering as positive direction. So whatever the objects which are given in the question are moving in the same direction as the pulley, we can consider them in the positive direction, and reverse one we consider in the opposite direction, right? So xp here moving in the downward direction, that's why I am writing here xp is equals to displacement of pulley is equals to xa is moving in the downward direction minus xb by 2 by 2. And remember one important point here: if you differentiate the above equation, this is actually the equation in terms of displacement. If we if we differentiate the above equation, we would get velocity of pulley is equals to velocity a velocity b by 2. Similarly, if I again differentiate, we would get acceleration of a pulley is equals to acceleration of a acceleration of b by 2. These are the two cases. Now suppose this is the displacement of pulley, xp is equals to xa minus xb by 2. This is for second case. Now if I differentiate, vp is equals to va minus vb by 2. Again if I differentiate the equation, above equation, I would get acceleration of p is equals to acceleration of a minus acceleration of b by 2. These are the relations in representing. And the third condition says that, see very carefully, the third condition says that the pulley is attached at one end, and that means it is fixed at one end, and for the other end it is moving. Suppose if pulley is moving in the downward direction, this is also moving in the downward direction xp, then xa, then we can write it as xp is equals to the direction of the pulley we are considering as positive direction. So we can consider xa is also moving in the downward direction, means xy is also moving in the downward direction, means it is also positive, but other end has been fixed to the wall or ground. So that fixed point is 0, no displacement by 2. So xp is equals to xa by 2. And note here, if we differentiate this one, Vp is equals to Va by 2. Again, differentiation gives acceleration of acceleration of A by 2. This is what is basic formula for constraint relations. Right? Now, based on this concept, I would like to explain some diagrams which would definitely helps you in writing equations. Now, this situation says that this situation says that A block moving in the downward direction XA, B block moving in the upward direction XB, and what is the relation between XA and XB? This is what is the condition we need to find. And observe very carefully, if A is moving in the downward direction means this point is having XA. Similarly, this is the same thread, so this point will also have the same displacement XA. I hope it is very clear for you. And this has been fixed, it has been fixed. So the pulley is moving in the upward direction, this pulley, and the pulley displacement is similar to the displacement of the block B. The pulley displacement is same as the displacement of the block B. So can I write now xp is equals to xb. Now this is xa moving in the upward direction plus 0 by 2 because it has been fixed here. Now the relation between xa and xb becomes xa is equals to 2xb. And if they are asking what is the relation between the velocity of A and velocity of the B, then we have to differentiate the above equation, we would get velocity terms. And if they are asking us acceleration, then we would get acceleration of B is equals to 2 times of acceleration of A is equals to 2 times of acceleration of B. Clear? This is what is second case. Sorry, an example for the constraint relation. Let us see for the next example. Example 2. In the example 2, see very carefully. Here pulley is present, a block is present, its displacement is XA, and here one more block is present, and here its displacement is XB, and it has been fixed, Now with the same displacement as C block, that is xc. Now displacement of B is equal to xa. See very carefully again. B is moving in the downward direction. A is also moving in the downward direction. C is also moving in the downward direction. So can I say downward direction as positive? Then xa plus xb by 2. xb by 2. Sorry. xc by 2. xa plus xc by 2. That is xa plus xc is equal to 2xb. Is equal to 2xb. Now the next point is, if they are asking again differentiation means va plus bc is equal to 2bb. Acceleration means aa plus ac 2ab. 2ab. These are the three most important conceptual and applications of the constraint relations. Let us see some numericals over constraint relations topic. The first point is, the first numerical is, in the arrangement of 3 blocks as shown in the figure, the strings is inextensible. If the directions of accelerations are as shown in the figure, then determine the constraint relation. Note one point here. This is one block and attached with the pulley. And it is the given situation, and this is moving in the downward direction with the acceleration, let us say 1, 2, 3. So m1 moving in the rightward direction with an acceleration a1. This is moving in the leftward direction with an acceleration m2 a2. Then it is moving with the acceleration a3. Then what is the relation of acceleration between 3 blocks? And as per our knowledge of the concept, here we have seen xca is moving in this direction, means this point will move in the downward direction with an acceleration a1, and this is moving with the acceleration 2 in the leftward direction, means this point will have downward acceleration a2. Then acceleration of pulley is equal to acceleration of third block. Obviously it is moving with the acceleration which is equal to the acceleration of the block. So acceleration of pulley is equal to acceleration of third block, which is equal to a1 plus a2 by 2. a2 by 2. Then determine the constraint relation. So the constraint relation says a1 plus a2 is equal to 2a3. This is what the constraint relation says. Clear? Then next point, next example is, let us see second example. A pulley rope mass arrangement as shown in the figure. Find the acceleration of block m1 when the masses are set free to move. Assume that the pulley and ropes are idle. That says that in the question, suppose here m1, m2, m3, and here they didn't represent how much relatively an object is moving with respect to other object. So let us assume here it is moving in the downward direction. This one is also moving in the downward direction. This one is also moving in the downward direction with a1, a2, and a3. a1, a2, and a3. And again I am saying one most important representation is, if they are not giving anything in the question indirectly, you have to consider that every object is moving in the downward direction with respect to the ground. With respect to the ground. Right? Now a1 is moving in the downward direction. That means here it is moving in the upward direction a1. Now see, we are considering upward direction as the positive direction and downward direction as the negative direction. And with respect to ground I am taking, that's why finally we can consider a1 is moving in the downward direction, the whole arrangement is moving with some amount of acceleration. Then a1 is equal to a2 plus a3 by 2. a2 plus a3 by 2. Suppose if they are given relatively, then a1 is in the upward direction. So a1 is equal to minus a2 minus A2 minus A3 by 2. This is also one case is possible. This is also one case is possible. If relatively this arrangement is moving in the upward direction with respect to this pulley, if they are given in the question with respect to this pulley is moving in the upward direction means you have to consider this relation. And if they are not representing anything in the question, then you have to consider everything has to be moving in the downward direction, and it has to given acceleration as a1 is equal to a2 plus a3 by 2. This is the form. Sorry, this is the procedure. Now next one is third one. Two blocks A and B. Two blocks A and B of mass m and 3m are connected to a light string. One end of the string is connected to the block B and the other end is connected to a fixed point S. Very good, fixed point S. As shown in the figure, now a force F is applied to block B. Find the acceleration of block A and B. See, these type of questions require some extra information. That is, in this case, right, in this case force is applying at this point, and this is block B and this is block A with mass m with mass 3m. Now according to our observation, we can easily assume one point. If it is attaining an acceleration AB, it is attaining an acceleration AA, and here 5 threads are present. 1, 2, 3, 4, 5 threads are present. So 5 times of acceleration of B is equal to 1, 2, 3, 4 times of acceleration of A. This is one of the most representation. See, here 5 threads are helping to get the acceleration AB. Here 4 threads are helping to get the acceleration of 4A. So there is a relation 5AB is equal to 4AA. Right? Now next point is, by using sigma F is equal to MA, set of arm forces acting on an object to give a resultant acceleration A. For block A, then set of arm forces means 4T is equal to mass m into acceleration of A. This is the first point. Similarly, for block 3m, that is B block, see, I can say sigma F is equal to MA, F force is acting, minus 5T is equal to 3m into acceleration of B. Now see, can I do here one point? Let it be equation number 1, let it be equation number 2, let it be equation number 3, let it be equation number 3. Then acceleration of A is equal to 5 by 4 into acceleration of B. 5 by 4 into acceleration of B. Now 4T is equal to m 5 by 4 into acceleration of T. Acceleration of m, just substituting acceleration of A in the second equation, then we would get 4T is equal to m 5 by 4A. Then T is equal to 5 by 16 m AB, and I am substituting T value in equation 3. Substitute in equation 3. That gives us F minus 5 into 5 by 16 MAB is equal to 3m into AB. Now this becomes F is equal to 25 by 16 plus 3 into MAB. Now 16 30 to 48 plus 25, that is 73. So this becomes 73 by 16 m80 F. So acceleration of block B is equal to 60 F by 73 into m. This is what the acceleration of block A. And for block B, the acceleration of block A is 5 by 4 times of acceleration of B. Acceleration of A is equal to 5 by 4 times of acceleration of B. So which is equal to 5 by 4, 60 F by 73 m. This becomes 4, 20 F by 73 m. This is what is the acceleration of block A. This is one of the application advanced and critical problem in solving constraint relations. Even I am discussing here both concept as well as conceptual example, little bit application oriented problem and enough with them, but critical problem also I have discussed successfully, and I hope you understood my class very well. And if you need any extra effort from my side, better to let me know through comment box, right? And for our daily practice sheets and weekend examination papers, better to follow our Telegram channel. This is Jagan sir. Have a great day. Take care. Bye.